This film explains the working of a typical apparatus designed to deliver a continuous flow of nitrous oxide and oxygen, to which ether can be added as required. This diagram shows the general working of the machine. For the sake of simplicity, we are removing the spare cylinders, leaving one cylinder of oxygen and one of nitrous oxide. The carbon dioxide cylinder can also be disregarded, and so can the chloroform bottle, which is often provided. Nitrous oxide is represented here by a white dot. The gas flows from its cylinder through the lead to the flow meter. The symbol for oxygen is a white ring. This also flows to the appropriate flow meter. Here are the two gases flowing together as far as the meters. Next, they pass through their respective flow meters. The rate of flow is adjusted by thumb screws at the bottom of the flow meters. It is indicated by the height of a floating bobbin on a calibrated scale, the reading being taken from the top of the bobbin. The nitrous oxide scale is marked in liters to 10 liters per minute, the oxygen in cubic centimeters to 2 liters per minute, and the carbon dioxide in cubic centimeters to 1.5 liters a minute. The oxygen flow meter is fitted with a bypass. When the tap is turned on, large quantities of oxygen are delivered under pressure. After passing through the flow meters, the nitrous oxide and oxygen mix, flow past the ether bottle, past the rebreathing bag, through the corrugated rubber hose to the face mask. Here is the ether bottle in section, with gases flowing past the entrance. This arrow shows the direction of the gases. When ether is needed, the gases are diverted into the bottle, where they pick up ether vapor and carry it with them. A tap on the ether bottle controls this. Here it is turned half on. A portion of the gases continues to flow straight on. The remainder passes through the J-tube in the bottle, picks up ether vapor and rejoins the undiverted gases. Now the tap is full on, and the whole of the gases go through the bottle, carrying ether vapor with them. To increase the concentration of ether vapor still further, a plunger is used. It's attached to a hood which can be made to slide down over the open end of the J-tube. This forces the gases down nearer to the surface of the liquid ether, so that more is vaporized. When the plunger is right down, the gases bubble through the ether, and the concentration of ether vapor is at a maximum. Here we see the whole machine in action. Nitrous oxide and oxygen are flowing through the ether bottle, where they pick up ether vapor and pass on to the face mask. Before you start to give the anesthetic, you must check the whole apparatus. First, see that the cylinders are connected to the right flow meters. This is the oxygen lead. Follow it up to the oxygen meter. This lead is usually of white rubber. Now do the same with the nitrous oxide. The nitrous oxide lead is black. And again the same with the carbon dioxide. This lead is green. Now make sure that the cylinders are full. Don't trust the labels. The oxygen is in gaseous form, so the cylinder is supplied with a pressure gauge which indicates the contents. Before opening the cylinder, turn on the bypass tap to avoid any sudden strain on the pressure gauge. Turn the full or reserve cylinder key and read the pressure gauge. This confirms that the cylinder is full. Turn off the bypass tap and test the flow meter. Now turn off the cylinder. Next, test the in-use cylinder in the same way and leave it turned on. A pressure gauge would be of no value on the nitrous oxide or carbon dioxide cylinders because the gas is liquefied and the pressure remains the same until the cylinder is nearly empty. Open the spare cylinder and turn the flow meter control until the bobbin rises. Turn off the spare and open the in-use cylinder. Leave this open, but turn off the flow meter. Finally, check the carbon dioxide cylinder in exactly the same way. Ether decomposes in sunlight and in the presence of oxygen into poisonous aldehydes and peroxides, and it may become contaminated with chloroform if this has been used in the other bottle. If you are in any doubt, pour it away. In any case, the ether bottle should be emptied not less than once a week and refilled with fresh ether from the stock bottle. The ether bottle is surrounded by a can into which warm water may be poured. The water should be not hotter than 90 degrees Fahrenheit, or the ether may boil. As ether is vaporized, it cools, and the concentration of vapor falls. This water jacket delays cooling. Now assemble the corrugated rubber hose, expiratory valve, and angle piece. Slip the harness ring over the face mask and fit the mask into position. Then adjust the tension of the expiratory valve. Lastly, you should see that the rubber harness is at hand for use later on. You are now ready for the patient. If you feel his pulse before beginning, it'll give you a standard for comparison later. Make sure that he has had the correct premedication and that the record of preoperative examinations is in order. Examine his teeth and see if there's any obstruction to nasal breathing. Place the harness beneath his head to be ready in position when it's wanted. Turn the nitrous oxide on to a flow of 10 liters a minute. Next, clear the J-tube of any liquid ether. Turn off the rebreathing bag, raise the plunger, and turn the ether tap full on. The flow of gas through the J tube will immediately clear any liquid ether away. Now turn the ether tap off and the bag on again, and smell the mask to make sure that no ether vapor is coming through. Lower the mask gradually onto the patient's face. Induction will be slower this way, but much pleasanter. A mask held tightly on the face often produces a feeling of suffocation, which may lead to excitement in the second stage. As the mask touches the face, the rebreathing bag gradually fills. When it's full, the valve blows off at each expiration. The tension of the valve can be adjusted if necessary. A little positive pressure helps at this stage, but may tire the patient if it's maintained too long. The onset of the third stage of anaesthesia is marked by regular and sometimes stertorous breathing, often a sign of lack of oxygen. Now turn the oxygen on to 1 liter per minute. Provided the airway is clear, this will be sufficient for the 5 minutes or so until the ether has been brought in. Keep the chin well up, and if you put your hand on the patient's throat, you'll be able to feel the vibration of an obstruction that may not be obvious to the ear. Turn on the ether tap a little every 3 regular breaths. If the regular rhythm of breathing is interrupted by swallowing or breath holding, which you can see on the bag as well as by looking at the patient, turn off the ether. Lift the mask until the ether vapor is washed out of the rebreathing system, and then replace it. When the breathing's regular again, you can turn on the ether, as before, a little every 3 breaths. If you increase the concentration of ether vapor too fast and the patient coughs, turn it off again and remove the mask. You'll waste less time this way than if you persist with the ether and the patient develops laryngeal spasm. Start again with the tap a little short of the setting that produced the coughing, and move it up gradually. When the ether tap is full on, you can lower the flow of nitrous oxide by degrees to 5 liters a minute, without risk of the patient coming up to the second stage. One of the few dangers of nitrous oxide anesthesia is that prolonged oxygen lack may produce permanent cerebral damage. This setting, with 5 liters of nitrous oxide to 1 of oxygen a minute, passing full over the surface of the ether, will produce light to moderate anesthesia according to the resistance of the individual patient, and the proportion of oxygen will be sufficient even over a long period. The mask can now be strapped to the face by means of the harness, and the head turned to one side. If the breathing is not quite clear, insert an artificial airway. Provided the cylinders don't run short, the maintenance of anesthesia is more or less automatic, and you're free to concentrate on the patient's condition and to take blood pressure and pulse readings, a great advantage when he's seriously ill. For moderate to deep anesthesia, depress the plunger. But remember that there is a sudden increase in ether concentration when the plunger goes below the surface. This may lead to laryngeal spasm. Turn off the ether and wait until the breathing becomes clear. Take the mask away if necessary. When the breathing's regular again, you can turn on the ether. The patient is now being given a total of 6 liters of fresh gases a minute. His minute volume is probably about 8 liters. So that 3/4 of what he breathes will be fresh gases and 1/4 expired gases. This is called partial rebreathing. The rebreathing bag acts as a reservoir. To show how it works, we'll take each movement of the gases separately. The bag is filled partly by fresh gases from the machine and partly by gases from the hose blown back when the patient exhales. When it's full, the gases from the machine flow past the entrance to the bag down the hose. When the patient inhales, he draws gases from the bag in addition to the constant flow from the machine. As he exhales, the whole cycle starts again. The gases from the machine and those blown up the hose fill the bag. The flow continues down the hose when the bag is full and the patient inhales. Now let's see what happens nearer the patient. When he exhales, the gases in the hose are forced back towards the bag, and the hose therefore contains fresh gases in the upper portion and expired gases in the lower portion. These expired gases contain carbon dioxide, which is represented by black dots. Once the bag is full, about halfway through expiration, the remaining exhaled gases pass out through the valve. At the same time, and during the pause before inspiration starts, fresh gases from the machine are coming down the hose, pushing still more of the exhaled gases before them through the valve. When the patient starts to breathe in, there is about 1/4 of the expired gases still left in the hose, and he will inhale these together with the fresh gases from the bag. Now let's see the whole cycle again. The proportion of carbon dioxide breathed in is moderate, and at a flow of 6 liters per minute, a reasonable amount of rebreathing is maintained. If, however, the rate of flow of fresh gases is lowered, rebreathing will increase. As the bag fills more slowly, a higher proportion of the expired gases will pass up the hose, and less will be forced through the expiratory valve by the smaller downward flow of fresh gases. When inhalation starts, there will be a larger proportion of expired gases to be breathed in again by the patient, with a resultant accumulation of carbon dioxide. Conversely, if the flow of fresh gases is raised, rebreathing will decrease and will cease altogether when the flow is equal to or more than the minute volume of respiration. To sum up, the amount of rebreathing with a flow of 6 liters of fresh gases a minute is not normally excessive, and you should not give less, except when for some reason you want carbon dioxide to accumulate. If the patient becomes at all cyanosed, for example because of shallow breathing due to excessive premedication, you must be prepared to raise the proportion of oxygen. A patient who is suffering from shock or anemia must be given at least 20% of oxygen, even if cyanosis is not apparent. To do this, you can raise the flow of oxygen, or you can lower the flow of nitrous oxide, thereby producing more rebreathing, carbon dioxide accumulation, and so deeper respiratory excursion. As the anesthesia progresses, the patient's tissues gradually become saturated. After about half an hour, you will find that appreciably less ether is needed from the machine to keep him at the same depth of anesthesia. The cooling of the ether in the bottle results in some falling off in concentration, but you will usually need to turn it partly off. In any case, during the last 15 minutes of most operations, the ether can be turned right off. The nitrous oxide alone will be sufficient to keep the patient from coming round, and his reflexes should return within a few minutes of the end of the operation.